To the last chapter, um, chapter 6 is probably as much as any chapter that we cover is almost duplicated in Math 151. So if you're taking Math 150 or 151 next, and you do really well with this chapter, you're going to have an easy time in when you do this again. That you go a little bit deeper in college algebra than you do in intermediate algebra, but not that much deeper. So if you kind of rock this chapter and understand it pretty well, you're going to find it an easy chapter in college algebra, and you need all the easy chapters you can get. I'm going to scribble some stuff down right now that you should like copy into your notes and just kind of leave off to the side so you can see it. Won't make a heck of a lot of sense right now, but as I'm lecturing in section 6.1, it will certainly start to make sense. So just flat out copy this. I wrote too big. There's some more things I wanted to write that I'll try to scribble in maybe in a different color on this page, or maybe I'll flip on to another page. So just kind of take this into your notes, and I'll pull this sheet out a bunch of times as I'm going through this section and illustrate what this little notation is telling me or telling you. And I'll scribble something up on another sheet. So you can pause the video and take this into your notes, and then when you get it copied, I'll do another short little sheet. So I'll give you a few seconds to get that into your notes. Again, you can just pause the video if I start doing problems before you're ready. And you should just have all this kind of at your fingertips, and I'll explain how to use it, when to use it, and how this is supposed to help you get through this section. So section 6.1 is a section on combining two functions to make a new function, and algebraically it's an easy section. Symbolically it's a disastrous section, and it for me, and I have my master's in math, it wasn't until I got to my first graduate level math class that I really understood and appreciated function notation. So sitting in intermediate algebra, I mean, there's only so much I can expect in terms of your understanding of function notation, and you don't have to have a complete understanding of function notation, but the better you understand what the symbols are telling you to do, the easier this section and this chapter will be. Chapter 6, the thing that makes chapter 6 a tough chapter for some students is it has a lot of symbols in it that tell us to do certain mathematical operations that may not be intuitive. Algebraically, this is not a nasty chapter, but symbolically, it's a messy chapter. Oh, right. So, in section 6.1, we're asked to take two functions and create a new function with the two functions. And the notation here, a lot of students, because they're used to mathematics notation and how it's normally used, if they don't watch the videos or if they don't practice their homework, they start to do bad things. This notation, g minus f of x, this just asks me just to subtract the right side of the functions. So I'm going to do exactly what it tells me to do. You'll notice that in my little handout, I wrote f minus g and I put a minus sign followed by a parentheses. Well, this is g minus f. The notation's a little more involved. I did a little shorthand notation because mathematicians generally do shorthand. What this template is supposed to tell me is when I'm combining two functions into one, how to do that, whether I need parentheses or not really. So for g minus f of x, if I wanted to do that, I want to subtract each function. If I look at my little template for subtraction, it looks like this. Even though the order is backwards, the order I can fix up real fast. So if I'm asked to subtract two functions, I go to my little hint for subtraction, and this is the template for subtracting. Very specifically, I want to subtract the right sides of the functions. Because the g function is written first, I'm going to write the right side of the g function before the minus sign. And because f is written second, I'm going to write the right side of the f function after the minus sign. And in subtraction problems, you need a parentheses. If this was an addition problem, if this was f plus g of x or g plus f of x, I wouldn't need a parentheses. But I do here. So all of this problem is asking me to do is subtract the right sides of the functions. That notation to a mathematician just tells a mathematician, subtract the right sides of the functions and simplify. And I'm going to get to a final answer, and then I'm going to talk about what you don't do. So I'm going to just simplify this. So I'm going to subtract the right sides of the functions and simplify. So this is going to be 3 minus x. When I clear the parentheses that subtraction needs, the minus is going to attach to the 2x, and I'll get a minus 2x. And it's going to flip the sign in the parentheses. If it was plus, it goes to minus. If it was minus, it goes to plus. Now I'm going to combine like terms. So I'm going to write g minus f of x equals, and then the like terms are a 3 minus 3 and a negative x minus 2x. That negative x, I'm going to emphasize it's a negative 1x. The 3 minus 3s, these things cancel. And the negative 1x and negative 2x, you don't get an exponent when you're adding or subtracting. You just add or subtract the numbers to the left of the x's and leave the exponent. You don't change it. So the answer to this, I don't need to have the original problem with the answer, but it's kind of nice. It's just that. So that's all that this notation asks me to do. This notation just asks me to subtract the right side of the functions and simplify. What it doesn't ask me to do is it doesn't ask me to multiply by x. What the x does, it tells me not to change the x to something. For instance, had the problem been g minus f of y, instead of having negative 3x for an answer, the x in the parentheses says leave the x alone. Had it been a y in the parentheses, my answer would have been 3y. negative 3y. Had the problem been written g minus f of 7, I would have, instead of having an x in my answer, I would have changed the x to a 7, and my answer for that would have been g minus f of 7 equals minus 21. So the letter in the parentheses, it doesn't mean to multiply by x. Usually, when I have two parentheses next to each other, you multiply, but this is not that case. Function notation, unfortunately, borrows some symbols that have meanings in different contexts and uses them differently. So the parentheses x in each one of these problems just tells me I don't need to change the x to another number or another letter. If I did put a letter or a number there, at the end I would change my x to that number or that letter. So that's the first thing. So I do not multiply by x, even though it looks like it tells me to multiply by x. And I see this every semester when I grade the tests over chapter 6. So that doesn't mean to multiply by x. That's the first common mistake for, like, a student could do perfect algebra and then at the end multiply by x and get like negative 3x squared. And then they have to take off points. The second thing students do is they take the problem and set it equal to 0 and solve for x. So what I mean for the bad things, multiplying by x, if you went the answer minus 3x times x and wrote negative 3x squared because you thought this meant to multiply by x, that's wrong. Or if you took the answer and set it equal to 0 and solved for x and got x equal to 0, that's also wrong. So these are the things that students that don't completely understand the function notation and have a little intuition of mathematical symbols do wrong for the problems in section 6.1. Oh yeah, I'm going to skip all the problems between 40 and 48. They're not going to be on the video. You don't have to do those at all. So I'm going to stop at problem 38, and you'll stop at problem 39. So this is a really simple problem. Each of the first 9 problems are pretty simple problems. Each of the first 9 problems has an x in a parentheses, and that doesn't mean ever to multiply by x with function notation. That just means I'm not going to change the x to another letter or another number. And I'm working with the right sides of each functions, and it's really just getting a problem set up that needs to be simplified. That's all I'm doing. Question 2 asked me to subtract the functions. I went to my template. The subtract the functions, I know I need a parentheses. It looks to me like I need parentheses in subtraction and multiplication. I don't need parentheses in addition, and I don't need parentheses, and this is division here. So moving on to section number 4 in 6.1, the little time sign between means multiplication. I didn't have to write the multiplication symbol. If I would have written the problem just like this, that's the same. So a solid circle as opposed to an open circle means multiplication. An open circle means something else. So this is different. This is not the same as the open circle problems. This I read as g composed with f of x, and that doesn't mean multiplication. That's a symbol that looks like multiplication that doesn't mean multiplication. It is an operation that's completely unique to functions. So as I look at my little template, my template for multiplication says I need parentheses and 2 sets of parentheses. So when I go to do f times g, in this case g times f, I'm going to write an equal sign and I'm going to create 2 parentheses. Inside the parentheses, I'm going to put the right sides of the functions. So to do g times f of x, with or without the dot, I form 2 parentheses. Inside the first parentheses, because g is written first, I write the right side of the g function. I'm going to emphasize that the x there has a 1 in front of it. The second parentheses, I put the right side of the f function, which is 2x plus 3. And now I'm just going to simplify by foiling. So to get to my answer, I'm going to go g times f of x equals 2, and then I'll do firsts. 3 times 2x is going to be 6x. Outers, 3 times 3 is plus 9. Inners, negative 1 times 2x is negative 2x squared. Lasts, negative 1 times positive 3 is negative 3x. I'm going to write it in a nice order and combine like terms. So very specifically, for the nice order, I should probably have the x squared term first. So this negative 2x squared term I'm going to write first. And then the terms that can be combined are the positive 6x and the minus 3x. When you combine those, you get a positive 3x. And then the plus 9 kind of hangs around. I should have made another comment on this sheet. We usually will not factor our answers when it's a multiplication problem. The reason is it starts off factored. If I wanted it factored, I just wouldn't multiply this out. So we usually will not factor our multiplication problem answers. It wouldn't be wrong to factor this. This would be bottoms up factoring. I'd have to factor out a negative first. And if you look at the original problem before I got started, this is something that's factored. I probably would have just written the x first in this parentheses and called it done. So this would be a completely fantastic answer. If you really, really wanted to clean it up a little bit, you could definitely factor out a negative 1. It'd be okay, but usually, like I said, usually in multiplication, when we're dealing with multiplying functions, we usually don't do any factoring. But you could factor out a negative 1 because the negative in front of the 2x squared. If you did that, you'd have to flip the signs in front of the 3x and the signs in front of the 9. That would also be completely okay for an answer. What would be wrong is if I multiplied by x and or if I tried to set it equal to 0. So notice I do not multiply by x, and I do not set my answer equal to 0 and solve for x. And that's for every one of these problems. None of the problems on this whole entire section will I multiply by x or set my answer equal to 0 and solve for x. So that's all there is to do for number 4. These are really basic, simple problems if you understand what's being asked and don't overdo it and do something you shouldn't do. Problem 6 is the composition of functions. F composed with g of x. It has the same meaning for what it's worth. Some texts will not use this composition symbol. It has the same meaning. And I don't know that this is any better. As f of g of x. Probably neither symbol is terribly desirable, but the open circle doesn't mean multiplication. I read this as f composed with g of x, and my hint here to do f composed with g, I replace any x in the f function with the entire g function, and I'm going to need parentheses for both of these. I'm going to need parentheses. Sometimes I write a more detailed description on composition, but I've had bad luck getting too wordy with my description, so I'm trying to minimize my description, and hopefully this doesn't slow you down. So when I look at my instructions, I see the f function, 2x plus 3. I'm only dealing with the right sides of these functions. What I want to do is replace that x with the entire g function, which is just the right side, 3 minus x. So to do f composed with g, I replace any x in the f function on the right side of the f function with the entire g function. And you really do need parentheses. So where that x was, I'm going to put the entire g function, and when I do that replacement, I have to have a parentheses. So this is what f composed with g of x looks like. The problem doesn't ask this, and I might wind up asking this later. Had this problem, I'm not done with the problem, but I just want to been reversed. Had it been g composed with f of x, then I would replace any x in the g function with the entire f function. So because it doesn't say that, but this is the reverse. So had it said this, what I would have done, and this is not the problem, so I'm just going to block this off. What I would have done for g composed with f of x, I would have taken the g function and replace its x with the right side of the f function. So these are the two kinds of compositions that I might have when the functions are f and g. Later on, we're going to have letters like s and t or h and k, and I'm going to have to come up with a strategy for handling those as well, but it's going to be similar. So f composed with g, I replace the x in the f function with the right side of the g function, and I need parentheses. So this open circle doesn't mean to multiply the functions like the closed circle did. And in none of these problems do I multiply by x, nor do I ever set my answer equal to 0. So I'm going to clear the parentheses that I put in by multiplying 2 times 3 and getting 6, 2 times minus x and getting minus 2x. And now I'm going to combine the 6 and the 3. I'm ready to write my answer. My answer is going to be f composed with g of x equals to, I'm going to write the x term first, and the 6 plus 3 comes out to be 9. Again, I do not multiply by x, even though there's an x in a parentheses, so I'm not going to get negative 2x squared plus 9x. And I also do not take the answer and set it equal to 0. If you do that, and you write down a numerical answer, you're going to lose points on the test. So these are both wrong things to do, and you'll lose points. You could have a perfectly correct answer up until going too far. So overdoing it on these problems is worse than underdoing it, I guess. It's wrong to multiply by x. This just means don't change the x to another letter or another number. And never on these problems where we're adding, subtracting, multiplying, dividing, and composing functions do we set the answer equal to 0. 8's a nice friendly one, g plus f of x. If you look at my template is reversed, but it doesn't matter. I know that to do f plus g or g plus f, I'm going to have a plus sign, and this little template tells me I just don't need to worry about parentheses. So to do f plus g of x, my template tells me only in minusing and times do I need parentheses, or also in composition. So what I'm going to do is put the right side of the g function first, and again I'm going to emphasize there's a 1x there. And then after the plus sign, I'm going to put the right side of the f function. And I'm just going to combine like terms. So I'm going to go minus 1x plus 2x and 3 plus 3, and I'm almost right to my answer already. So g plus f of x is going to equal to, these terms combine to be positive 1x, because minus 1 plus 2 is positive 1. You can write the 1 to the left of the x, or I can just write an x, and the 3 plus 3 is 6. And that's all there is to do. It's just a base. The easiest problem is an adding problem. And again, I'm not multiplying by x, or not going x plus 6 equal to 0. So it would be very wrong. to go x plus 6 equal to 0, minus 6 minus 6, x equal to minus 6. You'd lose at least 2 points if you do that on a test. And the unfortunate thing is it doesn't matter how many times I say that. Every semester when I give the test over Chapter 6, usually about this time there's about 23 or 24 students left in a class that starts with 30. I would guess kind of 8 to 10 will do this if I gave this exact problem. I could give you exactly the problem that I did on the video, and 8 to 10 students will write an answer of -6 as opposed to just x plus 6. And it just doesn't ask me to do it, and it's wrong to do it. The next group of problems, I still use the functions f and g, but I create new functions. And when I create new functions, they're more complex because I want to kind of build with difficulty. So in the first 9 problems, I made the f and g as easy as I could make the f and g. Now in this section, this group of problems are a little bit harder. So I'm going to get started here. I just did a plus problem. I'm going to do another plus problem, and in plus problems I don't need parentheses. So to do number 10, I'm going to start off with my plus sign that's between the f and the g. I'm going to write the right side of the f function first because that's written first in the parentheses, so 2x squared minus 5x minus 3. Then this plus sign that's between the f and the g, and then after it, the right side of the g function, which is 5x plus 4. To simplify, I'm just going to combine like terms, which is minus 5x plus 5x and minus 3 plus 4. I'm probably ready for my answer. In adding and subtracting problems, because the problem doesn't start factored, if it does factor, you should factor. But what's left is not going to factor. So what's going to be left is the 2x squared that didn't have anything to combine with. The 5x's are going to cancel. The minus 3 plus 4 is a positive 1. And this doesn't factor. If it would factor, I would. It's a square problem with a plus, which are generally prime anyways. And even if this was a minus, that 2 would have to be like a 9 or a 25 or a 16 for this to be a difference of squares and factor into 2 identical parentheses, one with a plus, one with a minus sign. So this is prime, so it can't be factored. And I'm done. I don't ever multiply by x, even though that looks like you should multiply by x. I just don't change the x to another number or another letter. And I don't take my answer and set it equal to 0. So the worst thing you can do would be to do this. 2x squared plus 1 equal to 0 minus 1 minus 1. 2x squared equals to minus 1 divided by 2 divided by 2. X squared equals to minus 1/2. Square root plus or minus square root, x equals plus or minus the square root of -1/2. Solving for x, it's hard and it's completely wrong to do. If you did that if this was a test question, and if you did that, if you took your answer, set it equal to 0, and tried to solve for x, it's a guaranteed -2. First division problem, and the division thing says this: f divided by g. For the division, that means divide in function notation. I'm going to form a fraction. Because the f is written first, I'm going to write the right side of the f in the numerator. And the only time you can reduce is if you can factor and cancel. So I'm going to make an effort at factoring and canceling. We need to remember about fractions and when you can and can't reduce. Like this problem, x plus 3 times x plus 4 over x plus 3 times x plus 2. You could cancel the x plus 3's, but you couldn't cancel the x's or the 4 and the 2. When we're dealing with division, you can only cancel if the whole numerator is factored and you have identical factors. Something like this, x squared plus 7x plus 5, which is prime, over x plus 5. That won't reduce because I need exactly an x plus 5 in the numerator. There isn't exactly an x plus 5 in the numerator. The only way that I could cancel the x plus 5 in the denominator is if I could factor the numerator and get an x plus 5 in a parentheses. That's section something in chapter 2. Oh, God, I don't remember what part of chapter 2 it was, but kind of section I don't remember. Sorry, I taught it so many times, but we did dividing with fractions in the very first in chapter 2, and learned when you can and can't reduce. And so when I do this problem, my template tells me, or my little hint here says, I'm going to form a fraction with the right side of f in the numerator, right side of g in the denominator, and if I can factor and the factoring makes something duplicated between the numerator and the denominator, I'll cancel. If I can't factor, then I probably can't cancel. And if the factoring doesn't produce any matches between the numerator and the denominator, I also can't cancel. So first step, form a fraction. Right side of f in the numerator, which is 2x squared minus 5x minus 3 over 5x plus 4. I'm going to attempt to factor. So I'm going to do some side work here. It's bottoms up factoring. The 2x squared minus 5x minus 3. So bottoms up factoring is multiply. I'm going to multiply this 2 by that 3 and get x squared minus 5x minus 6. After I multiply for bottoms up factoring, I factor. This factors into x plus 1 times x minus 6. And then I divide, reduce, and bottoms up. So if this factors and has a 5x plus 4 in the factoring, then I can cancel the 5x plus 4. If it factors and doesn't have a 5x plus 4 in the canceling, then I can't, in the factoring, then I can't cancel it. So I started off multiplying by 2, finished the bottoms up by dividing by 2. First fraction doesn't reduce, so I bottoms up and get 2x plus 1. Second fraction does reduce, so I will reduce it. So I can go back to my work and say f divided by g of x equals to 2x plus 1 times x minus 3 over 5x plus 4. A 5x plus 4 doesn't cancel with a 2x plus 1. A 5x plus 4 doesn't cancel with an x minus 3, so I can't reduce this fraction. This I would consider the best answer. Because the factoring didn't lead to any canceling, I would live with this answer. It's really not the desired answer. Anytime, if a problem starts factored and I multiply it out, I'm not going to refactor it back. I'm going to get where I started. But if a problem doesn't start factored and there's something that can be factored in my answer, I should factor it. And so I formed a fraction, the right side of f in the numerator. I attempted to reduce, and the only way a fraction is going to reduce for us in this section is if you can factor and cancel. I did the factoring, but the factoring didn't lead to any canceling, so I'm done with problem 12. 14 wants me to do the reverse. That's not so hard. G divided by f of x. The only difference between this is I'm still forming a fraction when I see that division sign. The difference between the last problem that I did and this problem is, in this case, the g is written first, so it goes in the numerator. The f is written second, so it goes in the denominator. And again, this is, an okay answer, but not the best answer, because that denominator factors nicely, as I don't need to worry about doing bottoms up again. Just because that piece is in the denominator, it's not going to factor any differently. So I just factored it. I'm going to steal that 2x plus 1 times x minus 3 and throw it in my answer. So this is the best answer. And just like the last problem, no canceling can happen, because when you have a fraction, you have to have like an identical numerator and piece in the denominator, so I'd need another 5x plus 4 somewhere to cancel a 5x plus 4. 16 is a composition. It's a g composed with f. This is the easier version. To do g composed with f, I replace any x in the g function with the entire f function. So I look at the g function, it has an x there. That x in the 5x plus 4, I'm going to change to the entire f function. So to do this, I need parentheses when I'm doing composition. I'm going to replace the x in the g function. That's exactly what this says here. G composed with f. Replace any x in the g function with the entire f function. I need parentheses when I do that. So I'm setting up to do that. I'm going to change that x to the entire f function. The f function is 2x squared minus 5x minus 3. Now it's just a matter of simplifying, factoring if it factors. So g composed with f of x. I need to multiply everything in the parentheses that I imposed by 5. 5 times 2x squared is 10x squared. 5 times minus 5x is minus 25x. 5 times minus 3 is minus 15. I still have this plus 4. I'm going to combine those terms to a minus 11. So I'm going to get g composed with f of x equals 10x squared minus 25x minus 11. This is a nasty thing to try to factor. I'm going to attempt to factor it. Because the numbers are big, it's probably not going to be easy. This probably doesn't factor. So I'm going to attempt to factor my answer using bottoms up. So it's 10x squared minus 25x minus 11. I multiply and get x squared minus 25x minus 110. Now I need factors of 110. I'm not good at those. I'm going to try. 1 in 110. Now I'm going to go 110 divided by 2. So, whoops, mode, comp, 110 divided by 2. So it's 2 times 55. 3 doesn't go into it. How about 110 divided by 4? I don't think that goes into it. No, it doesn't go into it. 5 does. 110 divided by 5 is 22, so that's 5 times 22. 6 doesn't go into it because 3 doesn't. 7 probably doesn't go into it. No, I don't think 8 goes into it. 9 doesn't go into it. I don't think. I'll do 10. 10 does go into it. And this is all. These are all the factors of 110. I think. I could have messed it up, but I don't think I did. For this to factor, I need a pair of numbers that subtract to be 25. Those subtract to be 109. Those subtract to be 53. Those subtract to be 17. Those subtract to be 1. That's prime. It doesn't factor. So this is the ultimate best answer. I should not pull out the quadratic formula. The quadratic formula is absolutely wrong to use here. That's equivalent to setting your answer equal to 0, and you'll get numerical answers for x. And none of these problems between 1 and 18 do I get x equal to anything. So that's all there was to do for 16. 18's a minus, and in my minus template, I know I need a parentheses after the minus sign. So to do f minus g of x, I start off minus parentheses. First, I'm going to put the right side of the f function. So I'm going to go equals 2x squared minus 5x minus 3. The minus sign from the problem, and then the g function inside of parentheses that has a 5x plus 4. Now I'm going to get rid of the parentheses. So I'm going to leave the 2x squared minus 5x minus 3, change the 5x to minus 5x, the 4 to minus 4. And now I'm going to combine like terms. Minus 5x will combine to minus 10x. Minus 3 minus 4 combines to minus 7. So I'm going to get f minus g of x equals to 2x squared minus 10x minus 7. I'm going to attempt to factor that because it might factor, so I do that off to the side. So I'm going to try to factor. Because the problem didn't start factored, I should always attempt to factor. It's only in the multiplying problems. The multiplying problems start factored and you destroy the factor, and those are the only ones you don't factor. So bottoms up, I multiply, I go x squared minus 10x minus 14. Now my numbers have to multiply to negative 14 and give me a 10. So the signs are going to be plus and minus. I could do 1 and negative 14, or negative 1 and 14, or 2 and negative 7, or negative 2 and 7. Those are the only pairs for my pluses and minuses that are going to work. And none of those, these give me a 13 or a negative 13. These give me a 5 or a negative 5. This doesn't factor, so this whole thing is prime. And that doesn't factor at all, so this is my best answer. Because it doesn't factor, I don't go any further, and I absolutely shouldn't pull out the quadratic formula. It's very wrong to use the quadratic formula. So these are, I think, the harder part of the section. The rest of the problems, they look the same. I'm using the same functions. I give them different letter names just so you're not using F and G with every problem. And the big difference in the next section, instead of having this x in a parentheses, I have the number in a parentheses. And they're friendly. So for each of the problems between 19 and 30, I start off and I find an unsimplified, I don't think I could spell that right now, but I'm going to try. An unsimplified version of the problem with an x instead of the number that's actually given in the problem, which seems silly to do, but it's actually going to help. So I'm going to do 2 steps for all of these problems. And then I'm going to replace the x that I've used with the number from the problem and simplify. What I'm actually finding is a y as opposed to an x. X in this problem is -1. When I write my answer, I'm not going to say x equals. I could either write the problem next to the answer, or I could say y, because the number inside a parenthesis stands for an x. The answer I get stands for a y. So for this problem, I'm going to find an unsimplified version of the problem with an x. So this isn't the only way to do it, but I think this is the best way. So the problem doesn't have an x. I'm going to pretend it had an x. If it had an x, I would make 2 parentheses, because in multiplication problems I make 2 parentheses, and inside the first parentheses I'm going to put the right side of the h function, which is 2x plus 3. Second parentheses I'm going to put the right side of the k function, which is 3 minus x. Same right sides, new names, just to get us used to new letters. So that's the first step. I found an unsimplified version. I pretended the number was an x. That's going to help me get my answer really nicely. Now I can answer the problem. How do I answer the problem? I replace the x in this version with a -1 and simplify. So I'm going to go 2 times -1 plus 3 times 3 minus -1. Do it on your calculator if you don't want to do it by hand. So on my calculator I can go parentheses 2 times -1 plus 3 times 3 minus -1. The answer is going to be 4. It's technically y equals 4. It's definitely not x equal 4, because x is -1. So if I did this by hand and didn't use my calculator because I felt comfortable, this first parentheses is -2 plus 3, which is +1. The second parentheses is 3 plus 1, because a double negative goes plus, which is 4. And 1 times 4 is 4. So for my answer, for problem 20, I can say h times k of -1 equals to 4. If I want to, I can say y equal to 4. It would be wrong to say x equal to 4, because x is actually the number inside the parentheses, and in this problem it's -1, because that's what I changed the x to. So it's, sometimes it's just tempting to write x equals when you're getting a numerical answer. But in function notation, because it's a number to the right of an equal sign, it stands for a y. 22, k minus h of 0. First step, I'm going to pretend the problem had an x. Even though it doesn't have an x, for each of the problems between 19 and 30, I'm going to pretend the problem had an x, because that's going to tell me where to put the 0. You can definitely get to the answer without doing this, but I think it's I've had the best success with this. How do I do a minus? Well, with a minus, I need a parentheses after the minus sign. First, I'm going to write the right side of the k function, which is 3 minus x. Then the minus from the problem, then the right side of the h function, which is 2x plus 3. I don't need to simplify that. It's much easier to simplify with the number 0 than it is with the letter x. And in this problem, I have to change the x to a 0 anyways. So I'm going to wait till I change the x to 0 to do my simplifying. So I changed this x to a 0. I could put it in the parentheses if I wanted to, but I didn't really need to. And inside the parentheses, I could have put a times sign or a parentheses. So outside the parentheses, I have 3 minus 0, which is just 3. Inside the parentheses, I get 0 plus 3. And this minus sign I'm just going to bring down. The inside of the parentheses comes out to be 3, and 3 minus 3 is 0. So for my answer, I can write k minus h of 0 equals to 0, or if I want, I could say y equal to 0. They're both equally good answers. So if you're good at the top problems, these are way easier than the top problems, because instead of having to simplify with an x, you can simplify with a number. And I do way better simplifying with numbers than I do letters. 24 is a multiplication problem. It has that 4 in the parentheses. Temporarily, I'm going to pretend that 4 was an x. If that 4 was an x, I would form a multiplication by doing 2 parentheses. Inside the first parentheses, I'd put the right side of the k function. Inside the second parentheses, I'd put the right side of the h function. I don't need to FOIL that out because that's a mess to do. At some point I need to simplify, but I'm allowed to change the x to the number 4. So I'm doing that change. And again, if you need your calculator to reduce these, use your calculator. I don't care. I can do these, pretty quickly without my calculator. First parentheses, 3 minus 4 is negative 1. Second parentheses comes out to be 8 plus 3, which is going to be 11. And negative 1 times positive 11 is negative 11. So my answer can't say x equals, well, I could say x equals 4 because that's what it equals, but my answer could either be k times h of 4 equals negative 11, or I can say y equals negative 11. And if you wrote x, you'd have to say x equal to 4 because x is a number inside the parentheses. '26 is the evil composition, but it's not so horrible. So again, for all these problems, I'm going to pretend there was an x. To do this, new letters, to do this, I have to write the right side. I need to replace the x in the h function, because that's written first, with the entire k function. So to do h composed with k, I take the h function and change its x to the k function, 3 minus x. So the h function's written first. The open circle tells me to change the h's x to the k function. So I change that x to the 3 minus x, and you need parentheses when you're doing these open circles. I could simplify that now, or I can simplify it when I plug the 0 in. At some point I need to plug the 0 in for x. I like to simplify with numbers as opposed to letters if I can, so I will. So now I'm changing the x to a 0 because this problem tells me to do that. And this is going to be 2 times 3, which is 6, plus 3 is 9. So for my answer, that's the number 9 is the important part. I can say h composed with k of 0 equals to 9, or I can say y equal to 9. It would be wrong to say x equal to 9 because x is actually the number in the parentheses and it's 0 in this case. 28, another composition, and it's the same darn composition. It's still h composed with k. So for a start, my h composed with k of x, I've already done that right here. It's this. It's 2 times 3 minus x plus 3. So for every problem between 19 and 30 that has a number inside the parentheses, I like to pretend the problem has an x and get grounded what number I need to change to x. So now I'm going to change my x to a negative 2, do h composed with k of negative 2 equals 2 times 3 minus, since I have a double negative, I'm going to use a parentheses, plus 3. Inside the parentheses, I'm going to get 3 plus 2. So this whole thing comes out to 2 times 5, plus 3, which is going to be 13. So for my answer, I can write the problem next to the numerical answer, h composed of k of negative 2 equals to 13, or I can say y equal to 13. It'd be wrong to say x equal to 13. It'd be correct to say x equals negative 2 and y equals to 13, but it's not x equal to 13. K composed with h. To do k composed with h, backwards. K composed of h of x, I need to replace the x in the k function with the h function. So the x in the k function needs to be replaced, and for these compositions you need parentheses. What does it need to be replaced with? It needs to be replaced with the h function. So it's always the letter to the left of the open circle. Its x needs to be replaced with the function to the right. So this is k composed with h of x. Not going to simplify that. I'm going to wait to change the x to negative 6 to simplify. So I'm going to go 3 minus 2 times negative 6 plus 3. The inside of the parentheses comes out to negative 12 plus 3, which is going to be negative 9. So I'm going to get k composed with h of negative 6 equals 3 minus a negative 9. And then I get a double negative there, so I get k composed with h of negative 6 equals 3 plus 9. And for my answer, I can write y equal to 12, or k composed with h of negative 6 equal to 12. The next group of problems, it just calls out the more complex functions, but does the same sort of problems. So 31 through 39, new functions, new names, but the same functions. So for 32, I'm going to start working with an x. If I have an x and a minus, I need a parentheses after the minus sign. For this problem, I'd write the right side of the s function, which is 2x squared minus 5x minus 3 to the left of the minus sign. After the minus sign, inside the parentheses, I put a 5x plus 4. I could simplify that with the x's, or I can simplify it when I change the x to 2. For me, I do so much better working with numbers and simplifying than I do letters. That I'm going to do that. Feeling a bit lazy, I'm going to do this whole thing on my calculator just because it's a little bit longer than the last one. So let me see if I do 2 times 4 squared minus 5 times 4 minus 3 minus parentheses 5 times 4 plus 4. Close out my parentheses, hit equals. I get minus 15, assuming I did this right on my calculator. So it's completely okay if you don't want to do the arithmetic of the numbers by hand. If you could enter that string on your calculator like I did there, then you can easily get a correct answer of either s minus t of 4 equals minus 15 or y equals minus 15. Again, I'd have to say x equal to 4 if I wanted to say x in my answer. 34, s composed with t is a nasty with the x. So s composed with t of x, I need to replace the x's in the s function with the t function. That's horrible by hand with the letter x. So anytime I have composition, whichever function's written first, I want to replace its x's with the function after the open circle. So the s function had 2 x's. I'm replacing its x's with the right side of the t function. Fortunately, I don't have to reduce that. That would be a bear to reduce. I'm allowed to change the x's to 4 before I reduce. And if you want to do it with your calculator, that's probably better. If you don't want to use your calculator, it's okay. And do the parentheses first. Both parentheses simplify to be 24. So if I was doing this without my calculator, I'd go s composed with t of 4 equals 2 times, and then 24 squared minus 5 times 24 minus 3. Need to do the exponent next before I multiply. So 24 squared is 576. So this is going to be s composed with t of 4 equals 2 times 576 minus 5 times 24 minus 3. 2 times 576 equals 1152, so I get s composed with t of 4 equals 1152 minus 5 times 24 is 120 minus 3. So 1152 minus 120 minus 3, I get 1029 for my answer. I'm going to double check this and do the whole thing on my calculator. So this line right there, I'm going to try to do on my calculator. So I'm going to do 2 parentheses 5 times 4 plus 4 squared minus 5 times 5 times 4 plus 4 minus 3. I get that same 1029, so I feel good about my by hand work. I don't mind at all you doing this whole string on your calculator. It doesn't make any difference. If you want to do the arithmetic by hand because you like doing that kind of stuff, you're welcome to it. If you want to press buttons, you can do it as well. So 36 calls s composed with t again. Fortunately, I know what s composed with t of x is. So s composed with t of x is this horrible thing. 2 times 5x plus 4 squared minus 5 times 5x plus 4 minus 3. So this problem, I need to change the x's to 3's and simplify. I'm going to use my calculator to do the whole thing because I don't feel like thinking that much. So I'm going to go 2 times 5 times 3 plus 4 squared minus 5 times 3 plus 4 minus 3. If you just did the last problem, you're in a great position because we have basically exactly the same thing, except I had 4's in these parentheses. I'm going to just backtrack to my last problem that I got the ugly 1029 and change the 2 4's that I used in that problem to the 3 that I need in this problem. So now I have entered this very cleverly, and I get 624 for the answer to problem 36. So for my answer, could definitely do that by hand if you have the desire. You can go s composed with t of 3 equals to 624, or you can say y equal to 624. Wouldn't be right to say x equal to 624 because x is equal to 3. Last problem. T composed with s, and we're skipping 40 through 48, so won't worry about those a bit. So to do t composed with s of anything, I need to know where to stick my x. So I'm going to do t composed with s of x. The t is written first. I'm going to write the t function, but I'm going to change its x to the s function. So this is going to be 5 times, and then I'm changing the x to the 2x squared minus 5x minus 3. I'm leaving myself that plus 4. So these compositions are important to get good at. Whichever letter is written first, you go to that function and you get rid of its x, and you, in place of that x, you put the other function. You always need a parenthesis when you do that. So that's t composed with s of x. For this problem, I need to change the s to 1. So I'm going to go 5 times 2 times 1 squared minus 5 times 1 minus 3 plus 4. Although I could do that without my calculator, it's the last problem. I'm probably as tired as you, so I'm going to just mindlessly press buttons and make an exact copy of that. And I get negative 26, assuming I haven't pressed any buttons wrong. So for my answer, I can do t composed with s of 1 equals to minus 26. Or I can say y equal to minus 26. If I did this by hand, this would be 2 times 1. So this is going to be 2 minus 5 minus 3. And that's going to be negative 6. So this would be 5 times negative 6 plus 4. That's negative 30 plus 4, which is negative 26. So I could do it by hand, maybe even quicker than I could do it on my calculator. But by hand, if I'm getting fatigued, I make mistakes pretty frequently. And on my calculator, I make less mistakes because it's less mind work to press buttons than it is to do the mathematics in my head. So that's 6-1. The thing about this chapter is it's a longish chapter. It has 7 sections, then a review. And the stuff from the beginning of the chapter doesn't keep popping up again and again and again. So this whole section on operations with functions, it's going to be almost non-existent for the rest of the chapter. And when we get to the end of the chapter, you might completely have forgotten this lecture, especially because sometimes we take 3 weeks to go through this chapter. So you should come back and review it every now and then so you don't completely forget it when we get ready for the test. But anything that's test-worthy from this section will definitely be on the review. So I'm skipping 40 through 48, which you can as well. If you're interested in knowing how to do these problems, stop and visit me, and I'll show you how. They're not that hard, but it was long enough without doing those problems, so we'll hold off on those. The next couple sections are short-ish sections, so this can't be a bad thing. Okay, that's good.